Okay, welcome, Sarah and Michelle and Megan, Maya and Chan and Jessica, and those who are watching this as a recorded video, and also those who are about to log in. There'll probably be a couple more. This is week 2, so our second regular course webinar of the quarter. And before I share my screen and talk about our plan for today, Braulio has an announcement to make.
Thanks, Larry. Hi, everyone. How's it going? So I've set up my hours. Finally, well, I was available last week, but I have my hours ready for the rest of the semester or rest of the quarter. So you'll be, I'm just going to show you real quick where to find me. And so like, hopefully you can like stop by whenever you have any questions whatsoever, like any at all. Okay, so you log into Canvas and you start here. You go ahead and hit discussions, and you'll see I made a post.
All right, so we're gonna be finding you in a tent because that's all we see right now.
Oh,
it's a beautiful tent.
Hold on. You sure? How about now?
Much better.
Much better. Okay. So, you log into Canvas, you go to the proper class, you go ahead, hit discussions, and you'll see I made a post with titled Braulio's Tutoring Hours. I'll have my tutoring hours, like where the times I'm available and how to contact me. Here's my email. Here are my hours. I'm just going to show you real quick how to get to it. Click on this link, LTCC Cranium Cafe. It'll take you to all these cards of like all the offices that the college currently offers online, or services are offered online. Scroll all the way down until you hit Library and Learning Services, and that's where you'll find me. See, right now I'm online. To talk to me, you just go ahead and hit knock on door. If I'm not online, you can send me an email, or you can schedule a meeting for like a future date. If by chance you want to talk to somebody now and I'm not online, Kevin is the other stats tutor, and also Ian Lindelsey is the other stats tutor, and I recommend them too. They work just as well. But yeah, that's all for me. Hope to see you more throughout the semester. Thank you, Larry.
Great, thanks, Braulio. Braulio is a great resource, so definitely take advantage of it. I'm going to share my desktop now and talk about the plan for the day. Okay, so here's our plan. So the first thing that I always do is I'll answer any questions that you might have. And then I'm going to define what probability is. It's actually pretty simple to define, but not necessarily to do. That's just a big warning today, is that we're in chapter 3, and most students think that chapter 3 is the most difficult chapter of the entire quarter. So it's not very hard to listen to at all. You'll probably understand everything I say. It won't look hard, and then you do it yourself, and everything changes. So I want to give you a warning that make sure that you practice a lot, because that's how you get good at it. Watching me helps a little, but really it's the practice, what it's all about. So after that, the question is, will I win $200 million? Okay, and I will tell you, it's not a 0 probability that I'm going to win $200 million this week. And I'll explain that in a little bit. And then we're going to get into, these look really simple, and. So we're going to look in probability questions that have the word and in it, okay, or refer to something that is like and. Then we're going to look into or, and that's different than and we're going to look at how do you find a probability of this or that. And then we're going to get into given. So that's if you know this happened, now what's the probability? Because now that you know, it's probably changed what the probability is. So that'll be a given question. And then we're going to get into mutually exclusive, which basically means both can't happen together, but we're going to have a formal definition, a probability definition of that. And then we're going to get into independent events. So if you have two different events, are they independent of each other, or are they dependent of each other? And there's going to be some equations for that, and we'll work those out. And then finally, we're going to talk about project one. So project one is a big part of this class, so it's really important that you get going at it. And after today, you'll be ready. So that is the plan for today. So let me ask you, are there any questions about anything? This is the time. Okay, and anytime, but especially now. And I'll be happy to answer any questions if you have them. You can speak them, you can put in the chat box, whatever you think.
I had one question. I just wanted to put it out there that I was interested in maybe doing a study group, working on some of the exercises or worksheets on each chapter. So if anybody's interested in doing that, I'm Meg Chu.
Great, great. And I'm a total believer in study groups. I think they're really helpful. Not only are they helpful, but it takes some of the torture away from the class. I'll tell you, when I was a student, the first thing I did is I looked at the person next to me sitting in this big lecture hall. Of course, that obviously when I was a student pre-COVID, so we actually sat in a room, and we worked together. It made it so much more fun than to be all by yourself. So I strongly recommend, if you can work together, that's great. And I'm just not even going to talk about whether you can physically be in the same room together. I'll let you decide on that one. But you could definitely work. But you could
turn the TV off.
You can definitely work online together. Okay, and there's lots of study ways of doing that. So you can put in the chat box, email to each other using the Canvas message thing. But great idea, and again, I strongly recommend it. Not just for the project. Projects are absolutely required, but also it's a good idea for the assignments and studying for the exams. So, any other questions or suggestions?
Yes, Larry, I have a question. So when I was doing the chapter 1 and 2 homework, I had to log out of, or I had to use a different window to access the statistic calculator. Is that how it's set up?
Okay, so that's a good question. For the homework, you're gonna need a new tab, and you'll notice I always do that too, right? When I showed you last week, and I'm gonna show you again today, I'm gonna go to another tab in the browser, and that's gonna happen. For the exams, it's gonna be very different. For the exams, I actually physically embed, I guess I don't know physically, but programmatically, I guess, embed the calculator right into your exam question.
Okay, thank you.
But for homework is different because there's no Proctorio, there's no proctoring. You could use whatever you want for homework. So you could have 2 computers in front of you to do homework. Does that make sense? Okay, and since you reminded me, I now have chapter 4 with the LibreText calculator for the long video, although I haven't closed captioned it yet, so I haven't done a full public thing. But I'm working on them. I don't know if I'll be able to do them all. It took me about 10 hours to do that video, just to let you know how long these things take me. So I'll do them as I can do them. But at least I got chapter 4 will be online real soon as I close caption it. Okay, so it's an hour long. And if you ever made a video, an hour-long video, fully edited and stuff like that is really hard. It takes a long time. So I got 4 and I'll work on 5 next. 1, 2, and 3 I figure it's too late for those. So I'm gonna see if I can stay ahead of everyone after that. If not, then I might miss a chapter. They take forever, but just a note. So, and that shows you how to use your calculator while I'm doing the chapters. So it's more explanation of the calculator, and so do the short videos. Okay, so hopefully that answers your question about the calculator. Other questions? Okay, if there's no questions, let's get into probability. So let's talk about, first thing, you probably have at least a bit of a feel for probability. Maybe, maybe not. And I don't mean you're experts in it, but you've heard the word before, I'm sure. At least I would guess so. But I have in my hands something that I used to really be into. Can you all see that? Okay, so these are cards. Not only that, they're cat cards because I like cats so much. So they're cat cards. And the question, just to note before I write down, the formal definition, but if I mix my deck and I pick a card, what is the probability that this card is an ace?
1 out of 52.
What's that?
1 out of 52.
Okay, that's a good try. That's a good try there. So let me remind you, for those who don't know, there are 52 cards in the deck. How many aces are there in the deck?
4.
Oh, that's right.
There's 4 of them. So it turns out the probability that this is an ace is 4 out of 52. Does that make sense? Because there's 4 different aces that this could be. Okay. So given that, I can define formally what probability is. And probability is always a fraction, just to note, in terms of definition. So the definition is the following. The probability of an event, how about A, doesn't matter what letter we call it, occurring, is, and now let's write it. It's not great in equation, but it'll do what we can do, is the number in A, oops, I need to go fraction first. There we go. So it's the number, and I'll make this big because right now it's really tiny, in A divided by the total number that can happen. So let's make, let me write probability of A. And let's make it much bigger. And it's so important, I'm going to not just make it big, I'm going to make it red. I want it to scream out at you. So the probability of an event occurring is the number in A, so the total number divided in that makes the event happen, divided by all the different possibilities that can happen. And that is the probability of A. So the reason why the probability that this is an ace is 4 out of 52 is there are 4 aces. So there's 4 ways of the event happening, right? Clubs, diamonds, hearts, and spades. And there are 52 cards in the deck. Okay, and by the way, just to note, I would never test you on knowing anything about cards because I don't think that's fair. But I feel comfortable at least lecturing on it, even if, because you're not tested, it's no stress. So if you don't have to like know how to play every card game or anything, but it works really well for probability. So I tend to use this as for examples. Any questions on that example? Okay, so I could do lots and lots of examples. Sometimes the probabilities are easy, sometimes they're hard. All right, so how do you think I'm going to win $200 million? Any thought? There is a reason why I might win $200 million.
You have to play to win.
Which I did. Now, I won't know until Tuesday night, but I played Mega Millions. Okay, so you got it. You have to play to win. And I played. Okay. In fact, I play once a quarter and it's for this class. And do you know how many times I've won the big money? Yeah, exactly. 0 times. So I would not come into my house and rob me because I have this $200 million ticket. Okay, it's a little more than that actually. And we'll see why it's not worth robbing me right now. Any questions on the question? So the question is, what is the probability I won Mega Millions? Because that's what I played. I think it's capital M.
Do we have to know how many people played in order to determine the number of chances you have?
It actually doesn't matter how many people played. If there's a lot more people playing and more than one person wins, we both win. We just don't win as much money. So I'm not going to say probability of 200 million. I'm really going to say just probability I won Mega Millions. Okay. And when I mean win Mega Millions, the big money, I actually won $4 once. And that was, you know, I wasn't that excited about it. And I want to show you something. I don't know if you can see, but there are 3 sets of numbers here because I bought 3. Got it? Cost me $6. Just let you know. So I bought 3 of them. So the good news is that, at least I hope you can all tell me, the probability, let's call it win, is equal to, well, it's a fraction. Let's do the really easy part first. What's the numerator? The hint is it's really easy. What is it?
3.
3, because there are 3 different outcomes when they pick their lottery numbers in Sacramento or wherever they're doing it. I don't even know who does it. There's 3 different outcomes that will make me the big winner. Got it? Now comes the hard part, and that's the denominator. So to understand the denominator, let me ask, has anyone played Mega Millions before? Maybe you know exactly how it works. Okay, so if you don't, good news is we have the internet. Internet, you can find anything. So I'm going to click on Mega Millions. And then I'm going to hit how to play, because that's what we need to understand. All right, so what we see is the following. The step 1 I already did. Okay, and that is the very beginning is I went to the place to buy the ticket, but now comes the interesting part. I pick 5 numbers between 1 and 70. Got it? Okay, and 1 mega number between 1 and 25. Any questions on this idea? So let's go back here, and just a note in here, I'm going to pick 5 from 1 to 70 and 1 from, let me get it again, that was 1 to 25. Any questions so far? So we need to find out how many ways are there of picking 5 numbers from 1 to 70. Any questions on the question? Okay, by the way, there's a lot. For example, you could pick 1, 2, 3, 4, 5, 1, 2, 3, 4, 6, 1, 2, 3, 4, 8. I can go on and on and on, and I probably die before I finish. There's so many of them. Got it? So the last thing I can do is list them because there's too many. But here's the good news for you guys. Took me a little work, but not my lifetime. And that is I created a calculator in there called combinations and permutations. And what you do is if you want to find out how many ways there are of picking 5 numbers from 1 to 70, and it'll be 70 because we're picking out of 70 possible numbers. R will be 5. And there's CNR and PNR. It turns out CNR is what we want. Okay, so that's C stands for combinations. It's all the combinations of a list of numbers from 1 to 70. And what it really has to do with is PNR means that 1, 2, 3, 4, 5 and 5, 4, 3, 2, 1 are a different list. But for the lottery, those are the same list. I'm not sure if you know the rules of the lottery, but those are the same list. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. That's the same set of numbers, it turns out, for the California lottery for mega numbers. So I'm going to click calculate CNR. Okay. You need to round this. There's some computer issues. I should probably fix that someday. So it's a lot. Okay. In fact, we're going to round this, but it's hard to even read this number. It's so big. We're talking about 12,103,014. Any questions on that? So 12 million, you don't have to memorize this number. What you want to do is understand that if you want to pick a certain amount from a larger amount, that's how you do it. Okay, so 12 million, what I have to do is write it down so I can rewrite it. Or actually, I don't have to write it, I'll copy it. That works. So I'm going to put down, well, let me do it here. Change that 3.9 to a 4, because it really should be rounded. And then down here, I'm going to put 1, 2, 1, 0, 3, 0, 1, 4. But I'm not done yet. Why not? What haven't I done yet?
To pick your numbers for 1 through 25.
Yeah, the number from 1 to 25. Okay. Well, it turns out the way it works mathematically is that if you're going to pick a number from this group and another number from this group, and what you did on this group has nothing to do with what you did with this group, you can multiply the two. So again, what you picked from 1 to 70, you're allowed to pick the same number from 1 to 25. Not sure if you know that, but you are. So that tells us I take that and I multiply by, hopefully everyone knows, how many ways are there picking a number from 1 to 25? A single number. It's so easy. You should all know.
25.
Exactly. It's 25 ways of picking a number from 1 to 25. Notice there's a big difference between picking one number and picking 5 numbers. Okay. Well, this one we could do in the calculator. Let's see if I can make it happen. No. So 1, 2, 3, 1, 2, 3, 0, 3, 0, 1, 4. 1, 2, 3, 0, 3, 0, 1, 4 times 25 is a lot. Okay. We're looking at 307,575,350. In fact, I think I'm going to make it easy on myself. Hit enter because Google's really good about this. Then I can just copy it in. So what I'm going to do is, that's going to be 3 again, over that huge number. Okay. So should I, get a big loan now because I'm going to be winning so much? What do you think? Should I count on it? No. In fact, if you do this division, it's about 1 in 100 million chance that I've got the big winner. Does that mean it can't happen? What do you think?
It can happen.
It can happen. It can happen. But I'm not holding my breath on this one because it's very unlikely. So this is an example of a probability question. And, it's quite complicated. I'm not going to get into any of the details on how this 120,123,030,1,4 happened. You just need to know that calculators do it. Got it? Okay, there is an equation and it involves factorials and all kinds of mess. I'm not going to go into it. Sound good? And you're going to hear that a lot from me, by the way. Okay, if you ever really want to find out, you can always come to my office hours and I'll torture you because I do know the math behind it, but I don't make you know the math behind it. What I want you to be able to do is understand how to put things together. And that is, if we have two different things that one doesn't affect the other, you can just multiply them. Any questions on that? And then the big definition that probability is always a fraction. Okay, any questions at all on this lottery example? All right, so let's move on. This looks so easy. Is this a word that you all know? And? Doesn't that look easy? But things get harder than you think. So let's do, I'm gonna do some examples. Okay, suppose you pick 2 cards. So here we go. I got my deck. I'm picking a card. And then I'm picking another card. Notice they can't be the same card because I didn't put it back in the deck and read. You're looking at 2 cards here. And I'm not cheating. This is a real deck of cards. So you pick 2 cards. Find the probability that they are both hearts. Any questions on this? Okay, the first thing is, let me reword this. And you always want to be doing that if you can. We want to find the probability. I'm going to reword it with symbols now. In fact, let's do it as an equation form, make it pretty. We want the probability and we can think of this means the first card we picked was an H. It was a heart. Call it H1, meaning first was a heart. And the second card is also a heart. Let's call that H2. Any questions on how to take this sentence and turn this into an problem? Any questions on that? Okay, now I'm going to throw some notation at you. Okay, and by the way, I gave you a list of things we're doing. They're not quite in exact order because you got to do them all together. So what we can say is this is equal to, well, it's equal to the probability that the first was just a heart. Right? If the first isn't a heart, you've lost. You didn't get your 2 hearts. Got it? Okay, but if you got the first being a heart, now we want to find out what's the probability the second is a heart. Any questions on that idea? And we're going to multiply just like we did in this lottery example. So that's going to be the probability, and the notation we're going to use is H sub 2. So the second is a heart. I'm going to put a little line segment. You read that as given. H sub 1. So here's the idea. If I want 2 hearts, so I look at the first heart. If it's a heart, I still got a chance. Any questions on that? If it's not a heart, it's over. So it's only if it's a heart that matters. Well, if this one's a heart, now we want to find out the probability that the second card is a heart. Will that be the same as the probability that the first card is a heart? What do you think?
No.
No, how come? What's going wrong here?
You have fewer cards to choose from.
Yeah,
Fewer,
exactly.
fewer hearts.
Both actually have fewer hearts to choose from, but there's also fewer cards left in the deck. Any questions on that idea? So what I'm going to do now is work it out. And again, probabilities are fractions. The probability the first is a heart. How many hearts are there in a deck?
13.
13. And again, if you don't know cards, that's okay. I'm not going to require, but if you don't, then trust me that there's 13 hearts. Okay. And by the way, a heart really looks like it's a heart. See the little heart there with the cute cat? So that's a heart. Okay. So if you don't know cards well, then that's a heart. Okay. So 13 over what? For the first one being a heart, out of how many cards?
52.
52, because there's 52 cards in the deck. Then I'm going to multiply that by the probability that the second card is a heart, given the first card was a heart. So how many hearts are there for the second card to be a heart?
12.
So
There's 12 because we already saw a heart, so it can't be that one. So now there's only 12 left. Out of how many cards?
51.
51, because we already saw a card, it can't be that one. So we start at 52, and there's one that it can't be. So now there's 51. Any questions on this calculation? Let me make it bigger because I know it's tiny. I can't always control it. There we go. Now it's more readable, right? Any questions on that calculation? Okay, again, my big warning is it's not that hard to watch me do it. And then I give it on a test, and what happens? It doesn't go well. Yeah, it's hard because it's a lot of words. Okay, and I'm the one that kind of read through the words and kind of talked it over on how you take the words into symbols. And that's what you're going to want to do. Any questions on this idea? Just a note, we're going to do another thing. Now we're going to say, I'm going to pick a card. Can you see the card I just picked? Do you know what it is? You can't see the card. You can see the back of the card, but you can't see the card. Okay. So I'm going to pick a card and I'm going to put it down. I'm going to pick another card. What's the probability that this second card is a heart? What do you think?
It's still 12 over 51, isn't it?
No, it's 13 over 52
Okay.
because you haven't seen the first card. Do you see?
Mm,
There is a first card. It's over here somewhere, but there are 15 hearts that you could list that this could be. And there are 52 cards you could list that this could be. So this given thing only matters if you're actually told what it is. Do you see that?
yes.
Otherwise, it's not, doesn't change the numbers. It only changes the numbers if you see the first one, then you know the first one, so now it can't be the first one. If you don't see the first one, then the second one could be any of 52. Just like if I took the deck and I said, I'm going to take all 51 of these and I'm going to put them down here. What's the probability the bottom is a heart? I bet you all would have gotten that right. And you would have known that was 13 out of 52. Same idea. Any questions on this?
Mhm.
Okay, I put that in because a lot of people make a mistake on that one. So I try to go over the things that get people. Any questions on this idea? Okay, now let's do a kind of a wordy problem. I think it's worthwhile. Suppose that 20% of all students taking stats at LTCC are African Americans. It's capital. And how about 40% of all stats students at LTCC are non-STEM majors. I'm totally making this up, by the way. I have no idea, but good numbers, right? Okay. If 22% of LTCC non-STEM majors are African American, and you pick a randomly selected, non-STEM LTCC stat students. Non-STEM majors are African American, and you pick a randomly selected African American taking stats. Find the probability that the student is non-STEM. Any questions on the question? Okay, I wanted to give you one like this because sometimes you'll get these on exams or quizzes. And what makes this problem hard? What do you think? Any ideas? Okay, what makes this hard is there's a lot of words. It's just one big fat paragraph, and you have to be able to read through all those words and be able to turn it into a math question. Do you agree on that? Maybe you're all saying that's easy, but I doubt it. Most people have trouble with these problems, a lot of trouble. All right, so what I recommend doing in these kind of what I call wordy problems is taking all the numbers given and turning them into symbolically. So I'm just going to read the problem again. And every time I see a number, I'm going to turn that into symbols. So 20% of all students taking stats at LTCC are African Americans. So what I can do now is I could say the probability, let's call it A, African American. A lot easier than typing the whole word. And what is that equal to? Not a trick
20%.
question.
Yeah, yeah, 20%.
Yeah, how do you write that as a decimal?
2.
0.2. So what I recommend is taking all of the numerical information and turning it into symbols. So 40% of all students at LTCC are non-STEM. So how about probability of, how about N for non-STEM? Sound good? And that's equal to 0.4. Any questions so far? Okay, 22% of LTCC stat students, non-STEM majors are African American. What's that the probability of? Any thoughts? Okay, I'm hearing some different tries, which is good. So let's look at what we've got. Okay, so 22% of, after the word of is the whole population. Well, the whole population only includes non-STEM majors. So the given is the N. That's going to be on the right-hand side. After the word are, that's what the probability is. So it's going to be probability of A given N. Anyone lost on that? That is very difficult for most people that I've worked with.
Can you repeat it, please?
Okay. Oh, I forgot to write the number. So P of A given N is equal to 0.22. But
Okay.
You wanted the explanation repeated?
I would appreciate that, actually.
Okay, so the idea here is that after the word of is your population. So our population are the non-STEM majors. Do you see that?
Yes.
So we've restricted our population to a smaller group. When you restrict to a smaller group, that's a given. So that means the N is on the right-hand side of the given.
Okay.
Right? Now we say 20%, 22%, blah, 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 are African-American. So that means we want the probability, that means the probability of African-Americans
Okay.
within this restricted population, that means given N is equal to 0.22.
Thank you.
Okay, and by the way, you are not alone. This is hard. Okay, this is really hard for students. And practice, practice, practice helps a lot. And you'll get problems like this on your homework assignments too. Okay, so if we pick a randomly selected African-American taking stats, find the probability the person's non-STEM. So what is the question? We want the probability of what? How do we write that in symbols? Any ideas? Okay, I don't see all of you having ideas. Okay, so the idea is that we're picking an African American. We're not asked if we picked an African American. We're picking an African American. So that means African American is the given. We want the probability of non-STEM. That's the question. The question comes first. The given comes second. So now we want N given A. All right, equals question mark, because that's what we want to find out. Any questions on reading the sentences and turning them into symbols? Okay, so now that we've got that, the next step is to work out some formulas. So probability of N given A is equal to, okay, notice in this other example, we had this equation, but here the given was together with something else. Mathematically, how do we get the given by itself if we have multiplied by probability of H1? What do we have to do to both sides? If we want to get the probability of H1 given H2 given H1 by itself, what do we have to do to both sides?
Subtract H2.
That won't do it.
Okay.
We have something times what we want equals this probability. We want to get rid of the something. How do you get rid of a times, something that's multiplied?
You divide.
Divide.
You divide. So in particular, you divide by the probability of H1. So we could say the probability of H2 given H1 is equal to the probability of H1 and H2 divided by probability of H1. So similarly, the probability of N given A is equal to, well, we're going to have a divide. So we're going to have the probability of N and A divided by the probability of A. Let's make that bigger so it looks better. Any questions on that? What if I can bold it, if it'll let me? Maybe not. Any questions on that idea? Okay, now we just work out what we can. We need the probability of N and A. But here's the thing, we know the probability of A given N is 0.22. Well, 0.22, probability of A given N is the probability of A and N divided by the probability of n. For the same reason what we just did before. But the probability of n is 0.4. So now I can multiply left and right by 0.4. And 0.4, let's write it out. 0.4 times 0.22 is equal to the probability of A and N. So now I'm ready to put it all together. So this is equal to, I'll write fraction, probability of N and A, which is this 0.4 times 0.22, which, by the way, is 0.0822. Sorry, 0.088 is what I want. You can do that in a calculator if you want. Divided by the probability of A. Probability of A was 0.2. And 0.088 over 0.2 is what? It's 0.44. Any questions on this? Let me ask you, do you agree that this is hard to do? A lot of thinking. The arithmetic is quite easy, especially if you have a calculator, but it's coming up with what to do is the hard part. Any questions on this idea? Okay, let's do another type of example. And I want to do what's called a contingency table. You might have seen it, so I might as well show it to you. So secret word is given. Once in a while I don't need to, but it's okay. So the secret word is given. And hopefully you remember in probability, that little vertical line segment is given. Probabilities with given are really important. So the secret word is given. So you got it? Okay, don't forget to write it down because I'm not coming back to it. Let's just push it way down. Okay, so contingency tables. So let me do my example because that's the best way. A survey was done. By the way, if I ever say a survey was done, I'm making it up. A survey wasn't really done, but pretend a survey was done. Asking students where they plan, let me go LTC students, they'll do our students. Where they, LTC, how about transfer students? Plan on transferring to. And not just where they plan on transferring to, but also how about what living situation they will be in when they transfer. And the table below shows the results of the study. So let me build a table. Okay, so the different places are CSU, UC, UNR, University of Nevada, Reno, and other. And living conditions are going to be apartment, parents, and other. And here's the results of the survey. It's going to make up numbers. Okay, now does everyone understand how to read this table first? Any questions? So for example, what does the number, let's go 33 correspond to? What does that mean?
"33 students are going to a UC and they'll be living in an apartment."
Exactly. There are 33 students that plan on going to a UC campus and live in an apartment. Any questions? Any questions on reading the table? Okay, so now the question is, there's a lot of different questions I could ask. How about find the probability that a randomly selected student will go to a UC campus or live in an apartment? Any questions on that? Okay, so I'm going to write down a big formula. So I'm going to go probability of, let's call it UC, or how about A for apartment? I always like to use something that starts with an A. And here's the big formula. This always works. That's the probability of UC and, UC plus the probability of A, apartment.
May you scroll down?
Yeah, that happens
Thank
sometimes. Thanks for letting me know. If you ever can't see, tell me. Because I can see and you can't, and it's always frustrating. So probability of UC plus the probability of A minus the probability of UC and A. So this is always going to work whenever you need an or question. You can write the probability of the first plus the probability of the second minus the probability of both. Okay, any questions so far? Okay, so the next thing we got to do is we got to find the total number of students. And you could use a calculator. I'm going to do quickly in my head. We got what? 76, 80, 95, 97, 117, 151, 159, 166, 181, 201, 220, 246. So there's 246 students. So note there are 246. By the way, you're welcome to use a calculator. You don't have to use your brain calculator. Calculators, if I were doing it for exam, I'd never do it in my head. In fact, don't trust that I did my calculation perfectly because I went really fast. So you're always welcome to use a calculator, which will be in the embedded test for the test. Okay, so what I'm going to do is I'm going to do fractions because probabilities are fractions. So the probability of the UC First thing, what did I say for, now I forgot. What did I say for the probability, the total, there it is, 246. That's why I wrote it down. So it's 246, and that's the total. How many UC students are there? UC transfer to UC. Kind of a nice number. It's 33 plus 8 plus 19, which is 60. Let me do the following. Let's make this bigger. Fractions always go too small with Google. So plus. Now we want the probability of an apartment. So again, we're going to have a fraction. So we have apartment, 43 plus 33 is 76, plus 19 is 95, plus 22 is 117, divided by 246. And then minus the probability of UC and A. Okay, you all should be able to tell me how many are in UC and A. Yeah, 33. So it's 33 over 246. Any questions? Any questions on this? I think I'm going to spare you the, watching me do it, but I hope you know how to stick this in a calculator. So I'm going to assume you know how to put that addition and subtraction in a calculator. It'll take a while, but I can do it if I have to. Any questions on solving this problem with the OR problem? Okay, next definition is two events, A and B, are called mutually exclusive. If the probability of A and B is equal to 0. Okay, so that's the formal definition. It's important you know that equation. It's a very simple one. And basically what it says is that you can't have A and B both happen, because that's what it means for probabilities to be 0 for what's called a discrete distribution. Let me put that in red because it's an important word and it's vocabulary. Okay, so here's a question. Are transferring to a CSU and living with parents mutually exclusive? What do you think? Any thoughts? So are those mutually exclusive events?
No.
Right, they're not. And the reason, again, you need to write it out. So the probability of CSU and P for parents. Let me not use P. I'm going to go parents. P looks too much like probability. Is equal to, well, 34, because there's 34 that are CSU and parents, over 246. And I hope you all know that that is not equal to 0. So therefore, they are not mutually exclusive. Okay, notice that transferring to a CSU and transferring to a UC, those are mutually exclusive. You can't do both. Does that make sense? The probability of transferring to both a USC and a UC for any individual person is 0. Any questions on that? You're only allowed to transfer to one university. Hopefully you know that. Okay, so the next definition is 2 events are independent if any of the 3 are true. And let me write 2 events A and B, give them names. And independent is the big thing we're defining, so I'm going to make it red. So the first is that the probability of A and B is equal to the probability of A times the probability of B. Second is the probability of A given B is equal to the probability of A. And third is the probability of B given A is equal to the probability of B. If any of those 3 are true, they're all true and they're independent. If any of those 3 are false, they're all false and they're dependent or not independent. Any questions on this big definition? Okay, so an example. How about living with parents? How about an apartment? And transferring to UNR independent. Any questions on the question? Okay, so we actually have 3 choices. We could either check this guy, probability of A and B equals probability of A times probability of B, or we can check this one, probability of A given B equals the probability of A, or we could check this one, probability of B given A equals the probability of B. All right, the first one is harder than the other 2. How come? Any thoughts? Okay, the first one has 3 probabilities to calculate. Do you see that? Whereas the other 2 only have 2. Okay, so if you're not given any probabilities already, it's easier to do the second or the third. Sometimes you're given probabilities, you don't have a choice, but if you're not given any, the second or third are usually easy. In this case, I think it doesn't make any difference whether you do the second or the third. So how about the second? So let's check. So let's find the probability of, now we're looking at apartment given UNR. Any questions so far? It's going to be a fraction. And to find the probability of living in an apartment given that they're at UNR, what given means is that we're told that they're in UNR. So it means all the other columns are not part of the question. If you're given that they're in UNR, then we only focus, we pretend we only know these three numbers. We want to find out the probability they're in an apartment. How many are in an apartment in this column?
$19.
There's 19. And how many are in the column total? That might take some arithmetic.
$41.
Good, 41. So this probability is 19 over 41. Let's make that bigger so you can see it. Okay, now we need to find what is the probability of just A. And the good news is we've already done that. That was 117 over 246. So I can actually copy and paste it, I think. I think it'll let me. Okay, are those the same fraction? How do you find out if two fractions are the same? Given that you have a calculator, what's the easiest way? How do you find out if two fractions are equal? Any thoughts? If you don't remember. Okay, turn them into decimals. See if you get the same decimal. So 19 over 41, I'll use my favorite Google. And I get 0.4634 about. And 117 over 246. I get 0.4756 about. So now it should be obvious. Are they the same? Let's double check that. Yeah, 4756. So are they the same? Yeah, they're not. They're not that different, but they're not the same. Since they are not the same, transferring, or how about living in an apartment and transferring to UNR are dependent, not independent. So in this case, they're dependent. Had I used any of the other equations, I would have gotten the same thing, dependent. Any questions at all on doing this calculation and understanding independence? Do you believe me that this is going to be hard when you have to do it yourself? Or does it look really easy and it's like, nah, I'm going to be able to do this without like worrying? What do you think?
It's hard.
Yeah, this is going to be hard. So I want to give you some words of advice. First is work, practice, practice, practice. If you're working on a homework problem or other kind of problem and you can't figure it out, what should you do?
Email or office hours?
So either office hours or Braulio. So Braulio's hours. So my office hours are Braulio's hours, either way. Not email. So if it's something where other people are going to benefit from, because that's not a personal thing, right? How do you do a question? Where are you supposed to put it? Do you remember?
Discussion. Q&R. Q&A.
Yeah, I think that's what you said. Q&A.
Yeah.
Good. Yeah, you put in the Q&A discussion board. So you can copy and paste it or type it however you want, and then I'll answer too. So again, get help, because most of you are going to need it. Okay, it doesn't just happen. I check my the Q&A often. Braulio has lots of hours. I have some hours. So there's a lot. We're here for you. What you shouldn't do is say, well, yeah, I'll just get it wrong and not worry about it, because that'll come back to bite you on the exam. So make sure you learn how to do these problems and try to figure out the rationale. Okay, as I mentioned often, first step is to write them in symbols, and then use the formulas that I've gone over, plug in, and then try to do your best. Any questions on this? Okay, so I'm done with chapter 3. Let me talk about the big thing that's coming up. And I'm going to go to the syllabus. Okay, I know it's a while from now, but it is actually the first major item that has a date. Okay, May 2nd. I know that seems like forever because it's only April 12th right now, but don't wait till the last minute to start on the project. As I mentioned, there's one thing hopefully all of you are already done, which is
Posting the discussion, looking for a partner?
Yeah, or even better, find a partner. Hopefully you did more than post. Hopefully you actually got your partnerships. So hopefully you have your partnerships. If you don't, then you should be very concerned at this point. You need to get those partners, okay? 3 is best. 2 is okay. 3 is best. So that's a big thing. Any question about that so far? Okay, due May 2nd does not mean you should work on it in May 1st. That's a bad idea. So let me go through the project. And we talked a little bit about last week at the orientation, but now it's time to get into the details. Okay, project 1, students will collect quantitative data and use a computer to display each of the charts discussed in class. Okay, so do you remember the 3 charts I talked about last week in the webinar? You remember?
Histogram,
Uh-huh.
box plot,
Uh-huh.
and I think time.
No, time happened in the
Stem and leaf.
stem and leaf. Yeah, time happened in the discussion post for this week, but not, that might be why you're thinking the time series plot. But stem and leaf, histogram, and box plot. So 3 of those need to happen. Other plots are okay, but you have to have those 3 for sure. Okay, any questions on that? Okay, I'm going to click on project 1. And this gives requirements. Okay, so the first thing, by the way, you've already hopefully done. If not, you need to do soon, and that's get partners. The next step is think of a quantitative investigation that someone might have contract you to have done. And when I say investigation, I mean a survey. So you do a quantitative survey of people. Okay. Now, because we're in COVID times, that means unless you're in a special exception, that means online. Okay. The special exception is if you work with a lot of people, and it could work that way, but I do not want anyone to get COVID because of this project. Got it? But the chance of getting COVID by asking someone online is 0. Just let you know that. Okay, that can't happen. That's a probability is what I should say is 0. Okay, so here's the first thing you're going to want to do. Once you've chatted with your group, come up with your investigation. Then what you should do is you should post your idea on the Project One discussion board. And what you should post is your survey question and your sampling technique. So let me read this piece. You need to description of your sampling technique, and you must use random sampling, stratified sampling, or cluster sampling. Here's a big warning. Remember what I said about random sampling of people? We talked about that last week. Remember what I said about how easy that is to do?
Too convenient?
No, not too convenient. It's much, much worse than that. It's the opposite.
Too broad?
It's impossible. So if you think you can random sample, good luck. Okay. I've had very, very few groups successfully do it. So almost all of you are going to use stratified sampling or cluster sampling. Got it? So in your post in the Project One discussion board, explain your sampling technique and how you're going to go about it. So stratified sampling, I have links to talk about these, which we talked about last week, but it's so important that you need to, look at that. I'll let you look at the link to remind yourself what they are. What I recommend for stratified sampling, if you can do stratified, is don't do multiple types of strata. So don't do age and gender and race. That's just too much work. I won't give you more credit if you do 3 strat types. Just do a single type. And the single typical types are gender, race, kind of age group, sometimes political affiliation, but don't choose more than one of those if you can do stratified. Got it? Okay, there's a few others that you can use also. Okay, depending on your survey. Okay, and then cluster sampling. Remember that cluster sampling does not involve just one group. It means you're going to talk about all the different clusters that could happen. And the clusters should be a reasonable sample size each. And then you're going to pick a few representative clusters. Got it? Okay, once you have done that, then what you should do is look at my comments because you posted it up on the board, and I'll let you know whether it can work. Usually I say, yeah, that looks good, except here's a couple things you might want to change. Okay, sometimes they're minor, sometimes they're major. One thing I recommend doing to ensure that it's quantitative is ask your partner the survey question. And what should come out of the partner's mouth?
Number.
A number?
A number. If your partner does not answer the survey question with a number, it won't work. Got it? Okay. And it's a disaster if you don't have quantitative, by the way. Okay. It's not just some little minor thing. It's a complete disaster. It means the whole project won't work. So again, do that. That's a good double check on quantitative. Okay. You should also identify who your client is. By the way, this is a big word, might. This is all in theory. You don't have to have someone pay you. I mean, of course, if you can make money, go for it, but definitely not a requirement of this class. So that's in theory. So, I mean, that someone could be President Biden. It doesn't mean you need to call Biden and contact him. If you could, that'd be awesome, but good luck. But the point is that imagine who might be interested. If nobody's interested, it's not a good project. It's just not interesting. Any questions on that? Okay. You should also identify what your population is. So if you're doing a sample, to the sample, you got to think about what is your population. It might be all students at the community colleges in California. It might be all residents of your city. It might be, or all adult residents. There's all kinds of different populations it could be, but you should identify it. I want to mention, I don't think it's written in here, but here's a big no-no. No asking children. Do you know why? You know why I'm not going to let you ask any children?
You need parental consent.
Yeah, without signed parental consent, and it not just parental consent, actually. It first has to go through an ethics committee. Then you get parental consent, and then you can go and do it. Good luck. So don't ask children, because I don't want to get sued, and you don't want to get sued. Do you agree? So children are outside. You're not allowed. Children mean under 18 in this case, by the way. There is one type of child you're allowed to ask, and that is if you're asking students in a college class. I don't know if you know this, but their parents have already given consent. So I don't know if any of you are under 18, but if you are, your parents had to sign a paper saying they're giving consent on these kind of things. So if it's a 17-year-old taking a college class, no problem. Okay, if you're asking him in their college class, like if you're sending an email to the college students in a section or something. So that's the only child you don't have to worry about. Otherwise, you should worry. You can't do it. Got it? Okay. So then once I have looked at it, given you the okay, then you go out and you conduct your study. Again, most of you, not all of you, and most of you will do it online. Do what you have to do. The only people who tend not to do it online are, let's say you're a nurse, then you're allowed to ask your patients because you're there with them anyway. You won't get COVID because you got to be with them anyway. Does that make sense? So there are a few exceptions, but only a few. Okay. Or if you work at a restaurant, you can ask, and that survey could be how much they spent. So you don't actually have to vocally ask them. You could look at their receipt. Okay, so those are the kind of things that you're allowed to do, but you're not allowed to go like in front of a grocery store and ask, because then I can get in trouble. Sound fair? Okay, this is important. Let's write this part first. You need, then once you've conducted your survey, you're going to put it in the spreadsheet program. Okay, not the LibreText calculator, but this is the one I showed you in the orientation, the spreadsheet program. Do you remember that program? You put it in the spreadsheet program and use a spreadsheet, and that way this class transfers. Okay, you need to write about any bias. Okay, and I just want to make a note. If you think there is no bias in your study, think again. It's pretty much impossible to do a study with zero bias. So think deeply, come up with bias. I don't take off points if you have a lot of bias. I take off points if you don't identify bias. Do you see the difference? Okay, and just a reminder, bias means that either the mean is lower than the population mean, the sample mean is low, or the sample mean is high because of who you asked, right? So if you wanted to find out the height of students and you go to a bunch of basketball players, very biased because the average is too high. Do you see that? So think about whether it's going to be higher or lower than the population mean, whether your sample mean will be higher or lower than the population mean. And discuss that when you do your paper write-up. Got it? Okay, here's the next piece. The sample size must be greater than 30. Just a note, 30 is not greater than 30. What's the smallest sample size you're allowed to have?
31.
Exactly. So 31 is fine. 30 is not fine. 50 is fine. I don't recommend huge numbers because then you're going to spend all your time doing your surveying instead of all your time doing your write-up. Okay, and you want to spend more time doing your write-up. So I don't give you more points because you did 100 instead of 31. Does that make sense? So you could do 33 if there's 3 of you because that's like a nice multiple of 3. If you're sharing the work, that makes some sense, but I wouldn't do too much more than that. Any questions on that? Okay, I think I mentioned this last week. If you have the word random in your paper, I'll probably take off points because you're probably wrong. Okay, the only time you would have the word random is this was not a random study. It was a cluster sampling or it was stratified, but don't think that you randomly surveyed because that's not really possible. Okay, any questions on this? Okay, so you must include all the charts, which I mentioned. Okay, and when you're putting it in the spreadsheet, this is not a comparison study. So in terms of the survey, there's a single survey question, period. Don't do some big long survey. It's just one question you ask. The only possible other question is for stratified sampling. So if you want to stratify by race, then you're going to ask, what is your race? Okay, and then you're going to ask your main survey question. But what is your race does not go in the statistics at all. Okay, so you ask what is a race just to establish quotas. But what goes into the spreadsheet is just the survey questions answer. Any questions on that? Okay. You must prove that you use a spreadsheet, and you do that by copying and pasting the spreadsheet result columns into the project. Okay, so when I'm reading your submitted project, I need to see that piece of the spreadsheet. It doesn't have the whole spreadsheet, but at least that part that has the mean and the median and the Q1 and Q3. I showed you that last week. Do you remember? Yeah. So that just copy and paste. It's pretty easy to do that. If for some reason you have trouble copying and paste, you can always do a screenshot of that piece, like using stimping tools or something like that. Okay. You need to interpret all the charts. Okay, now I'm going to give you something that a lot of people have trouble with. I am not the audience for the paper. Who is the audience for the paper?
Whoever hired you or contracted you?
Exactly, your client. So your client is the audience. That might be President Biden. It might be the counselor at the college. It might be the owner of the restaurant. Okay, so that is who your audience is. Does that make sense? Okay, you can assume that your audience understands statistics, by the way, even if they don't. So if your audience is some restaurant owner and they don't know stats, pretend they do. Sound good? So that's just a note. Throughout the entire paper, you need to write down how is your client going to use the piece of information that you're writing about. So if you're writing about a histogram, how is your client going to use the histogram? If you're writing about the mean, how is the client going to use the mean at every piece of the paper? Okay, not just in the last paragraph. Got it? So not only are you going to do the 3 charts, but you can do all the summary statistics that I talked about last week. So that's the mean, the median, the standard deviation, Q1, Q3, the min, the max, outliers, z-scores, all those things. Remember we talked about that last time? Now I mentioned the standard deviation is the biggie. So let me show you this. If you don't have at least a full paragraph devoted to the standard deviation, you can't receive an A grade. Okay. So in the book, I never have enough time to do everything in these lectures, by the way. So just note they're in the long videos, they're in the book, and that is empirical rule and Chebyshev's theorem. So you need to read up on them. If you don't understand them, you can always post on the Q&A board. I'll help you with it. You can ask Braulio for help too. Okay, you can cut my office hours. But the empirical rule and Chebyshev's are really applications of the standard deviation. So that's all part of your standard deviation paper. Okay. The z-score is also part of the standard deviation, because remember that was the value minus the mean divided by the standard deviation. So it's all in that paragraph. Okay. Just a note, because a lot of people make this mistake. In the spreadsheet it says change this number for the x value for the z-score. I really mean it. The z-score is for a certain value of x. Values of x that are important are the minimum and the maximum to find out if they're outliers. And if the minimum's an outlier, for example, then the next lowest. See if that's an outlier. So you use a z-score to find outliers. Also, any important numbers. So for example, if your survey question was, how many hours a night do you sleep? Or how many hours did you sleep last night? Then 8 would probably be an important number to check a z-score of, because that's the recommended number of hours to sleep. Okay, and then interpret. Any questions on the statistics? Okay, and when I say interpret, I do not mean define it. I don't need formulas. Don't say I use this formula, because you didn't. You used the spreadsheet. I want to hear about how the client is going to use that statistic. What decision is the client going to make for the client's organization or business after seeing that statistic? So every time you got one, you got to write that out. Any questions on that? Okay. I'm not going to read every word of this, but basically this says what I just said. You should talk about how you could delve deeper into the topic. So maybe if you did another survey that was more in depth with like 5 different questions, what would you ask? Or also, how would you do another study to prevent the bias that you found out about? Does that make sense? And just a note, this paper is a paper. So it should be a paper just like any other paper you submit. It should have an introduction. It should have a body and a conclusion, just like any English paper. And also, this is obvious, but once in a while I get someone forgetting. Don't forget to put your names on the paper. Only one person submits it, by the way. One person in your group submits it. And then everyone gets the same grade. But make sure all of your names are on the paper. So all 3 of you, if there's 3 of you. So that I can make sure that everyone gets credit. Okay, just a note, I have a link to feedback that I've given in the past. I recommend looking at that so you don't make the mistakes that have happened in the past. Here's another big note. Let me go back. A few notes. One is, do not work alone. There are no exceptions to this. 25% penalty will be incurred on any student who cannot work with another student. The highest grade you could ever get alone is a C, and that would be if it was a perfect paper. So I don't know if I've ever had a student work alone and pass. So don't work alone. You have to have partners. Got it? Okay, the other thing, the project is due on a Sunday. that does not mean you should wait till the end. And in fact, strongly recommend you sending me your draft by the Thursday before 8 a.m. So even better is Wednesday, because you're probably not like me and waking up early in the morning like I do. But if you are, that's possible. Just to let you know, I read it on a first submitted, first read basis. So if you wait till 7:59 a.m. on Thursday, it might be another day before I can read your paper, because it takes me a while to read 10 pages or however long it is and give you lots of feedback. If you send it to me on Wednesday, then you're probably going to get it back on Wednesday. You'll hear about me on Wednesday or Thursday morning, probably. If you send it to me on Thursday early morning, it might be a while. Okay. I only read one rough draft. So don't keep sending me a draft over and over and over again. Any questions? Any questions about the project? Any questions?
Can there be more than groups of 3 or like a higher amount?
No, see, if there's 4 of you, you can split into 2 groups of 2. Do you see? So 3 is the highest number in your group that's possible in your group. Okay.
If
That's
somebody drops the class randomly, could we add a third person if they are also
Absolutely.
stuck?
Highly encouraged. Yeah. Yep. If someone drops, add a third. Okay. Or if you're a group of 2 and now you have only one, it's only you, find a group of 2 to join. Does that make sense? And then be the third. And again, they should be happy to let you in because you're going to do work for them. So that's why groups of 3 are better, because it's less work. Okay. And I strongly recommend, by the way, even if you divide up the project, make sure you read the other people's portion of it, because remember, you're getting the grade as a single group. So, you know, you can trust each other, but you definitely want to read and fix it and make it better, because everyone has certain things that they're really good at. And if you're a group of 3 and you're all helping each other, then it'll be a better project. Other questions? These are good questions.
Collecting the data, does it have to be divided up?
It doesn't have to be. No, and in fact, the times when it usually isn't, and when it's from somebody's work. Like if we have a nurse and the other 2 people aren't nurses, then, and you're going to do something in your hospital, then obviously you're not going to make the other 2 people go to your hospital. Does that make sense? So that's not a requirement. But what I do recommend is the person collecting the data, they should at least do some of the project writing, because otherwise the person collecting the data won't learn much. And so it's not as good for them for getting ready for the exams and stuff like that.
I know you gave the example of the nurses collecting data, but can you give another example of a possible way of collecting data?
Well, one is internet.
Not online.
Oh, not online. Okay, so most of it's from work. In the old days, there were a lot of examples, but nowadays you can't do it because of COVID. So if you work in a restaurant, for example,
okay,
then you can look at tips or how much people spend on drinks, or there's all kinds of things that, you know, quantitative data that come in restaurants, right?
Okay.
Or if you work in a supermarket, right, you're going to see lots of customers coming in, right? And there's a lot of number stuff. You can say, well, how many items are people buying? You know, that kind of thing. Does that make sense?
Yeah,
So,
thank you.
Yeah, or any kind of store, you know what I mean? Not just supermarket. So that would work. In the old days, there were so many different answers. Nowadays, because of COVID, I can't suggest you go out and, you know, literally go somewhere and ask people that has nothing to do with your work, because I can get in trouble and you can get COVID, and I don't want that happening. Yeah. So by the way, here's another requirement. If you're going to be asking in person, you must wear a mask. Got it? So that's a requirement. That's not how it was a year and a half ago. But now you got to wear a mask if you're going to be doing in-person anything. Okay, any other questions? Okay, and Braulio's been through this, so he'll help you out too. If you have just general questions about the project, you can also post on the project discussion board, because I read it often, and I'll answer that too. So I think I'm going to stop my share. And I'm going to stop the recording.